So here is the video for the 3.5 lesson that involves solving systems in 3 variables. Whereas a system with 2 variables represents the intersection of 2 lines, a system of 3 variables represents the intersection of 3 planes. And these are just 3 flat surfaces that you can see over here. I know this picture isn't the greatest, but you'll notice here these are 2 planes, and there's only one intersection point here where this line comes together. So I'll draw a little arrow to that. So the intersection is this straight line. You can think of a bar going through that point. That is the one section. When 3 planes to come together and that bar is shown right here, that has infinitely many solutions, because you can think of how many coordinate points you could put on that line. It'd be infinitely many. You can also have no solution where they have no point in common. So these 2 planes, you can see, they have this bar, and then these 2 planes have this bar, but neither one of them share anything with this 3rd plane, so it doesn't work. Same thing here. These 2 don't share anything, and over here, none of them share anything, so no solutions. If we go down here, we're going to use the same methods for solving system linear equations in 2 variables to solve them in 3. And our solution is called an ordered triple. So whereas before we were working with an ordered pair that was x, y, now all we're doing is we're plugging on that z, that 3rd dimension, excuse me. So let's just move this so I can write there. So if I want to solve this, the first step I'm going to take is I'm going to take 2 of my equations, 2x plus 3y minus c equals 0, x minus 2y minus 4z equals 14. And all I'm going to do is use the same elimination methods here that I have previously used with 2 variables. So I want to eliminate in this set the x. So I'm going to multiply this entire thing by -2, because when I do that I get -2x, I get positive 4y, and then I get positive 8z equals -28. So now this equation was just a step. I put some box around it so I know not to use it again. And then I'm just going to add down the way I usually do. So 2x minus 2x, those cancel. 3y, 4y is 7y. Negative z, 8z is 7z. And 0 minus 28 is -28. I now have a system here that only has 2 variables in addition to these. My second step is to take 2 other equations. So it can be 1 and 3, it can be 2 and 3, it just can't be 1 and 2 again. That wouldn't help me any. So here, I'm going to take 2 and 3, I'm going to write them down here just the same way I did. I'm going to put this equation off to the side because it'll become useful for me in a second. It's just a good reminder that that's what I'm trying to get to. So I'm going to take x minus 2y minus 4z equals 14. 3x plus y minus 8z equals 17. Now when I'm solving these 2, the key piece here is that I have to eliminate the same variable that I did up here. I can't choose to suddenly get rid of y or suddenly get rid of z. I have to get rid of the same variable that I did above. So I'm going to get rid of this x by multiplying that whole thing times -3, and I'm going to tuck it in here. I know it's not the best idea, but it works for me. Plus 6y positive 12z equals -42. Put a box around my preliminary step, and again add down. My x's cancel. I get 7y plus 4z equals -42 plus 17, which is -25. Sweet. Now what I can do with this is I can bring it over here next to my other equation. And I can solve this system of equation in two variables the way that I'm used to. So just like I was eliminating things over here, now I'm going to multiply this bottom one by -1. So I get negative 7y minus 40 positive 25. Box this so I know not to touch it again. And then just add down. 7y, negative 7y, 7z, negative 4z. Simplify, and I get z equals negative. Awesome. I now have one piece of my equation that I need. For my ordered triple answer, I now have the -1. The cool thing is, once we get one of our variables, we do not have to go through all of this process again. All we have to do is take this and plug it back into one of our two variable equations that we had up here and solve for our other variable. So let's plug this into our top one. We plug it in, we get 7y plus -7 equals -28. Solve the way you would. When we add the 7 over, we get -21, and then we get y equals -3. Awesome. We now have our second component to our ordered triple. I just put that up here. And now all I have to do is take these two pieces and plug them back in up here to my 3-component piece. So I have 2x. I'm just plugging them into the first one because that one's probably the easiest. Let's see if I can make sure you can still see it here. 2x plus 3 times -3, because we're just replacing that, minus -1 equals 0. 2x. That's not the right number. -3 times 3 is -9. Plus 1, 0. We get -8, but we're going to move that over, so it's going to be positive. And we simplify and we get x equals 4. We now have all 3 components. We're going to take each of those, plug them back in up here to our ordered triple. And we end up getting 4, -3, 1. And this would be the final answer that I box. Yes, it's a lot of work, but I think these are some of the most rewarding problems to do, simply because it's really worth that answer at the end. The other thing you can see here is that if you took this coordinate point and plugged it back into each of these, it would work. I'm not going to show you that because I've kind of already done it here, but this point will work for all 3, and that's what it means to be a solution to a system in 3 variables.